So in this video we discuss about problem related to IIR filter realization structures. So here the problem is for y of n is equal to minus 0.1 y of n minus 1 plus 0.2 y of n minus 2 plus 3 into x of n plus 3.6 into x of n minus 1 plus 0.6 x of n minus 2. So for this system, IIR system, so determine or find direct form 1, direct form 2, cascade and parallel realization structures. So the solution, so first take the system which is described in the difference equation, that is y of n is equal to minus 0.1 y of n minus 1 plus 0.2 y of n minus 2 plus here w of n, where w of n is equal to three into x of n plus 3.6 into x of n minus 1 plus 0.6 into x of n minus 2, right? So now if we apply Z transform on both sides in equation A, then y of z is equal to minus 0.1. Of course you know that the z transform of y of n minus 1 is nothing but z power minus 1 y of z from the shifting in the z n domain property, then 0.2 z power minus 2 y of z plus 3 into x of z plus 3.6 into z power minus 1 x of z plus 0.6 into z power minus 2 x of z. So now here from this y of z is nothing but if you common y of z, then you can get like this. Minus 0.2 z power minus 2, then 3 plus 3.6 z inverse plus 0.6 z power minus 2. Okay, so here consider this one as a B equation, this one as C equation, and now from this y of z by x of z is equal to what is that? 3 plus 3.6 z inverse plus 0.6 z power minus 2 divided by 1 plus 0.1 z inverse minus 0.2 z power minus 2, that is h of z, transfer function of the system. Consider this one as D equation. Okay, now based on these equations we can realize the form 1, form 2 cascade and parallel structures. The first one, direct form 1, direct form 1 structure. To draw this we need B and C equations, so that means these two, right? So here from B, so apply the here also Z transform, then y of z is equal to minus 0.1 z inverse y of z plus 0.2 z power minus 2 y of z plus w of z. And then coming to the w of z, w of z is nothing but 3 into x of z plus 3.6 z power minus 1 x of z plus 0.6 z power minus 2 x of z, right? Okay, so now based on these two equations we just realize direct form 1. Like here first implement the w of n. So here is a point, consider this one is nothing but w of n, and here input x of n, then here y of n. Y of n z transform means y of z, here w of n means w of z, x of n means x of z. Okay, right. Now then w of z is equal to 3 into x of z, that means here place 3, then here place here delay z inverse. Now you can get here z inverse x of z, then multiplier, that is 3.6. These two are added here. Okay, so and then here one more term is there, that's why. So here use another delay to get z power minus 2 x of z, then that is multiplied by the 0.6, then again use one more 2 input adder. Now here 0.6 z power minus 2 x of z, so is added to the 3.6 z inverse x of z, and that is added to the 3 into x of z. Now w of n is nothing but this one. Okay, now coming to the, after getting w of z, then using this you can implement this equation. That means w of z is there, that is added to the y of z into some multiplications. So now here is a y of z, so now so delay unit. Now this one is multiplied by here z power minus 1 y of z, which is multiplied by minus 0.1, that is added to the w of z, right? And then one more term is there. Now take another delay unit. Now here is z power minus 2 x of z, which is multiplied by the multiplier, what is that, 0.2, then here use the another adder, now which is added to this one. Okay, now in this way here you can get y of n. right? So here consists of two blocks. Right? This one is completely relevant to the numerator of h of z, and see here this one is completely relevant to the denominator, right? So if you observe this one, if you consider h of z, by observing this equation we can easily draw this one, direct form one. But here remember, here are adders are placed, here delay units are placed, and then in the middle multipliers are placed. So remember the step of structure. So blindly, so we just draw this diagram from this equation, right? So in this way, right? So that means numerator we have 3.6.6 multipliers. So now use 3.6.6. In the denominator 1, 0.1 minus 0.2. So now here, so inverse of particular, that means reverse the sign here for these two multipliers. So then minus 0.1 plus 0.2. So now similarly, how many what is the order of this numerator polynomial? 2. Here denominator also 2. So use the 2 delay units. So in this side and in this side. Now so simply use the adders and then construct like this. Okay, in this way, by observing this one, so we can draw this one. Okay, and here this one is related to numerator polynomial. That's why it is also said to be all zero system. And this is completely relevant to the denominator polynomial. That's why it is said to be all whole system. Okay, so this is the direct form 1 structure. Now coming to the direct form 2 structure. Direct form 2 structure. So now for this one also, so okay, here direct form 2 structure means, so consider the equations, h of z equation. What is that? Y of z divided by x of z, that is equal to, so here from the equation D, so what is that? 3 plus 3.6 z inverse plus 0.6 z power minus 2 divided by 1 plus 0.1 z inverse minus 0.2 z power minus 2. Okay, so now here in this case take the dummy variable, that is w of z in the middle. So now this y of z by x of z is rewritten as y of z by w of z into w of z by x of z. So now this here you just assign y of z by w of z is numerator polynomial, then w of z by x of z is nothing but 1 by 1 plus 0.1 z inverse minus 0.2 z power minus 2. Always remember, that means numerator polynomial is completely assigned to the y of z by w of z. W of z by x of z is nothing but 1 by remaining part. What is that? Denominator polynomial. Right? Now from this, firstly write the equation for y of z. 3 into W of Z plus 3.6 Z inverse W of Z plus 0.6 Z power minus 2 W of Z. Now here W of Z plus 0.1 Z inverse W of Z minus 0.2 Z power minus 2 W of Z is equal to X of Z. So now here write the equation for W of Z here, that is X of Z minus 0.1 Z inverse W of Z plus 0.2 Z power minus 2 W of Z. Okay, so now these two equations are realized using direct form 2 structure in this way. So firstly take here also X of n. So now here to get W of Z here, to get W of Z, so X of Z, then here use W of here X of n, here is a place W of n, here place Y of n, here we need W of Z from X of Z, then here X of Z minus 0.1 Z inverse W of Z. So now from this use the delay units, how many? 2, that's why here Z power minus 1 minus 2. Now here multiply this one with the minus 0.1, here multiply this one with the 0.2, then now just add this one with this. Okay, add this one with this, and then here also use the adder. So that means here W of n is nothing but Z inverse of W of Z into minus 0.1. So that is added to the 0.2 Z power minus 2 W of Z, and then that one also added to the X of Z. Okay, right. In this way, just finish this part. Then, so coming to this part Y of Z. So here Y of Z means summation of these three terms. So related to the W of Z, here is a Z inverse W of Z. So use the multiplier here 3.6. Here is a Z power minus 2 W of Z. So use the multiplier 0.6. Then here W of Z is multiplied by the 3. So now here use the adders. Now you can get like this Y of n. So here 3 into W of Z, then (3.6) into Z inverse of W of Z. Here 0.6 into Z power minus 2 W of Z. Okay, right? So in this way, so you can get the Y of Z. Okay, right? So this is said to be direct form 2. So this one also by observing this equation you can directly draw this structure. Like first place the delay unit in the middle. So here is a 1 unit Z power minus 1. So okay, what is that? Z inverse. How many? Here 2, here 2. That's why here 2 delay units. Now use the multipliers, right? So right side numerator, left side denominator. So inverse the denominator multipliers, and then here as it is place the numerator coefficients. And now here use the adders like this. You may finish this one. Okay. So here conceptually using this W of Z, Y of Z we may draw. Otherwise, so here by observing this equation, just remember how to draw this one. You can finish it quickly. Okay, right. So this is nothing but direct form 2 structure. Now coming to the cascade form realization. Okay, here firstly take h of z, so that is 3 plus 3.6 z inverse plus 0.6 z power minus 2 divided by 1 plus 0.1 z inverse minus 0.2 z power minus 2. Cascade form means we should convert this one into the form like product of individual transfer functions, right? So okay, here second order polynomials are there, so we just build two individual transfer functions with the polynomial order 1. Okay, that's why here this is equal to, so find the roots here. So 3, if you common 3, 1 plus 1.2 z inverse plus 0.2 z power minus 2 divided by here 1 plus 0.1 z inverse minus 0.2 z power minus 2. Okay, here 3. So if I write this one, right, so to find out the roots here, so if I write 1 plus z inverse plus 0.2 z inverse plus 0.2 z power minus 2. So here 1 into 0.2, 0.2, then 1 plus 0.2, 1.2. It's okay. In this way. Now denominator 1 plus 0.5 z inverse minus 0.4 z inverse minus 0.2 z power minus 2. That means 0.5 into 0.4 means minus 0.4 means minus 0.2. Yes, here it is that one. Now 0.5 minus 0.4 is nothing but 0.1. Okay, that's why. So now find the roots here. One is 1 plus z inverse, another one is 1 plus 0.2 z power minus 1. The next one is 1 plus 0.5 z inverse, another one is 1 minus 0.4 z inverse. If you common 0.4 here, here you can get the 0.5, right? 1 plus 0.5 z inverse, if you common, then you can get 1 minus 0.4 z inverse. Okay, right? So now in this way you can write z h of z. Okay, this is nothing but 3 into h1 of z into h2 of z. 3 into h1 of z into h2 of z. Okay, now here h of z is 3 into h1 of z into h2 of z, where h1 of z is nothing but 1 plus z inverse by 1 plus 0.5 z inverse. h2 of z is nothing but 1 plus 0.2 z inverse by 1 minus 0.4 z inverse. Okay, now just realize these two using direct form 2. So I am using direct form 2 realization structures. Here structures to realize h1 of z and h2 of z. It's okay. Now First input is x of n. Here product is 3. Now we should develop h1 of z, then develop h2 of z using direct form 2, then you can get y of n. Right, now so x of n, product 3. Now here h1 of z means this one, so simply by seeing this one you can easily develop this one. In what way? First place the number of delay units. Here is only 1, that's why z inverse, and then here in the right side place the numerator polynomial, what is that equation? 1 plus z inverse. Z inverse product is 1, so that means no need to include here product, right? So just directly write this one. Now here use the summer. Now here is in the denominator place multiplier, that is value minus 0.5. Of course you know that inverse the sign. Then here use the summer. Here use the summer. In this way. Okay, so this is nothing but h1 of z. Now coming to this one, next part, what is that? So use the z inverse. Now so here take the multipliers for the numerator 0.2. Here the multiplier is minus of minus 0.4. Now here use the summer. Here also use the summer. Now you can get the here resultant one, y of n. Okay, so here in this way you can realize h1 of z, h2 of z. So using direct form 2 structures, and this one is for the, what is that, cascading form of realization structure. Okay, right. And then coming to the next one, what is that? Parallel form realization structure. So parallel form realization structure means so here h of z is, we know that, what is the h of z here? 3 plus 3.6 z inverse plus 0.6 z power minus 2 divided by 1 plus 0.1 z inverse minus 0.2 z power minus 2, right? So now here parallel form means we have to apply partial fraction expansions, right? So partial fraction method means here numerator polynomial order should be less than denominator polynomial order. To follow this, here first do the division here. Okay, so division means, so like this, 1 plus 0.1 z inverse minus 0.2 z power minus 2. Here 3 plus 3.6 z power minus 1 plus 0.6 z power minus 2. So here to reduce one z power value from z power minus 2 to z power minus 1. So first here multiply this one with the minus 3. Am I correct? So if you multiply this one with the minus 3 into minus plus 0.6 z power minus 2, then these gets cancelled, right? So that's why here 1 into minus 3 minus 3. Here is 0.1 into 3 means 0.3. Now plus 0.6 z power minus 2. Now here 3 plus 3 6 plus 3.9 z power minus 1. So these two are gets cancelled. Now this is equal to, what is that? Minus 3 plus 6 plus 3.9 z inverse by 1 plus 0.1 z inverse minus 0.2 z power minus 2. So h of z is equal to minus 3 plus, so here I am writing this one like this, a by what is that? This is nothing but, so okay, here 6 plus 3.9 z inverse divided by, so roots here for this 1 plus 0.5 z inverse. So in the previous case cascade form we have finished that one, 1 plus 0.5 z inverse, 1 minus 0.4 z inverse. Okay. Now this is equal to minus 3 plus a by 1 plus 0.5 z inverse plus b by 1 minus 0.4 z inverse. So here to calculate a here, so what we can do, 6 plus 3.9 z inverse divided by, here 1 plus 0.5 z inverse into this 1 minus 0.4 z inverse. So here in that one is multiplied with the 1 plus 0.5 z inverse. So these two cancel. Now use only this one. Of course you know that partial fraction method, that's why I am directly writing here. That means take this one, this particular part, right? Then here multiply this one with the 1 plus 0.5 z inverse, then these two are gets cancelled, then the remaining part this one, and then here place z inverse equal to, what is the z inverse here? 1 plus 0.5 z inverse, assign this one to 0. Now z inverse equal to minus 1 by 0.5, that is nothing but minus 2. Okay. Now assign this one, 6 plus 3.9 into minus 2 divided by 1 minus 0.4 into minus 2. Okay, what is the answer here? If you solve this one, you can get the answer minus 1. So 6 minus 7.2 divided by 1 minus or 1 plus 0.8. That means here minus 1.8 by 1.8 gives the value minus 1. Okay, A is minus 1. So coming to the next one, similarly B. So B means here same thing. Take this one, 6 plus 3.9 z inverse divided by 1 plus 0.5 z inverse into 1 minus 0.4 z inverse, that is multiplied by 1 minus 0.4 z inverse. These two gets cancelled. Now here place z inverse equal to minus 1 by 0.4 from this equation. Am I correct? 0. What is the z inverse? 1 by 0.4. Okay, 1 by 0.4. So that means here substitute 6 plus 3.9 into this one divided by 1 plus 0.5 divided by 0.4. That means 2.4 plus 3.9 divided by 0.4 plus 0.5. So that is nothing but this one, which is equal to 7. So A is equal to minus 1, B is equal to 7. Okay, so now h of z is equal to minus 3 plus minus 1 by 1 plus 0.5 z inverse plus 7 by 1 minus 0.4 z inverse. So here parallel form means it is like in the form minus 3 plus h1 of z plus h2 of z, like that. So that means here also we may write like this. What is that? Constant. Constant, right? So here constant is minus 3, h1 of z is minus 1 by 1 plus 0.5 z inverse, then h2 of z is (7 by 1 minus 0.4 z inverse). So now this one is like a constant, then next one h1 of z, next one is h2 of z. Here apply input, then add these, all this. That is nothing but our parallel form connection. So now here implement. Here is a minus 3. Now I am implementing h of z with the direct form 1. Now here is a z inverse. So here denominator means in this way minus 0.5. Now here use the summer. Now here minus 1 means here use the minus 1. Okay, here is x of n. Now the next one is nothing but here simply we change like this. Okay, so now again take the another one. What is that? This one, z inverse. Now multiplier 0.4. Now here use the multiplier 7, and then add this one to this, then this one to this, then you can get y of n. Right? So this is nothing but parallel form structure. Okay, so thank you.